right. Well, to kind of refresh everyone after two very interesting but, of course, very information-heavy talks, I'm going to start asking some questions. Who here has used MCP before? Either tool calling, wrote your own MCP servers? OK, a couple of hands. Let's go back one step. Who here knows what MCP is? OK, that's better. That's better. All right. Well, in this talk, it's going to be more about starting a discussion, starting some thoughts about what is the future infrastructure of the whole AI ecosystem. I think we all see that AIs are getting more and more prevalent in our day-to-day tasks. And tool calling is one way that they can integrate with way, way more than just generating text and images. What is tool calling? Well, originally, tool calling was just me as a creator of an AI agent or as someone who has an LLM. It builds an integration for my agent to be able to read my Gmail or use a browser or write files on my computer. All of these back then would need to be written by me for my agent, and this was a lot of manual work. So this is where we got the MCP, the Model Context Protocol, which standardizes this. It's designed to standardize how an agent or an LLM interacts with different tools by just making the agent create an integration for the MCP, and then MCP handles the entire rest of the communication. Basically, MCP acts as a translation layer or a middleman. And this MCP server that you see right there wraps around the tools so that it offers the tool and the agent-friendly way of calling the tool, and then handles all of the communication in the back. Now, the goal of MCP was basically to allow any agent to connect to any tool without the agent creating any custom code. And MCP did very well with that. Going more in depth with the architecture of MCP, I called it the mandatory middleman. MCP requires that every tool is placed behind an MCP server. And the agent requests are then proxied through this server to the tool. This kind of shows an essential flaw, which is part of this MCP protocol, which is whenever you want to add a tool to an agent, you need to reinvent the wheel. Instead of using the tool's native endpoint, whatever the tool was originally made to be interacted with, you now need to rewrite the whole thing in MCP, or at least a wrapper around it, so the AI can also use it. But AIs are smart. They can use a bunch of different things. And some of the problems that arise because of this mandatory middleman architecture are the following. First of all, I kind of call this the wrapper tax. So MCP not only just wraps around it, but also specifies a couple of transport protocols that need to be used so that the agent communicates with the tool. The problem is that those transfer protocols sometimes don't really make sense. If I want to use a tool which is a command line interface, I now need to make a live server for some reason, which I communicate with, and then the live server runs a CLI command. Additionally, now every tool also requires running a process if it doesn't have a process, like in that case, which is much more resource intensive. And finally, if your tool is in a language which is not standardly supported by the MCP protocol, in a transfer, for example, in this case, gRPC, MCP protocol only supports HTTP streaming and STDIO. Now, you as a tool provider have to figure out how do you host a server which can now run an HTTP interface for people to access your tool, which might be written in some sort of other transfer protocol. The second problem with the middleman is it actually forces the server creator to re-implement core services. Let's think about authentication. What happens in MCP is with authentication. Somehow, the person who, or the MCP protocol itself, needs to think, how do we now re-implement all of the things which have been already done for authentication? What about security, role management, permissions? What tools am I allowed to do? What tools am I not allowed to do? If all of these things need to be re-implemented within the protocol again. And finally, another example is just rate limiting. If I hide everything away a wrapper, how do I now implement the rate limiting once again for the whole protocol? So it's a lot of double work, either for the protocol itself or for the providers of the client and server. Third, there's a bunch of inefficiency. If that wasn't enough to convince you, I mean, yeah, you can obviously see there's an extra jump there. We need to talk to the MCP server before we get to the tool. We also unstructure the data because MCP always returns strings. So we might have really cool structured data coming from the tool, but MCP just transforms it into a string. So we lose all of that information. And actually, one of the whole things why we use MCP to be able to scale any client to any tool kind of gets broken. Because if you really think about it, if we have at a certain amount of tools, we won't be able to fit it all in the agent's context window. MCP doesn't provide any sort of solution for how do we search for tools, how do we sort which tools are relevant for our query. So now we have a problem. We need to, again, in our agent, implement a way to sort through tools, look through the tools, and see how do we rank and do this. And if all of this was not enough, the fourth problem is, in my opinion, way worse than all of the other ones, because all of the other ones can be solved by MCP itself. But the problem is this MCP standard is very brittle, because any change requires an ecosystem-wide change. So whenever the MCP fixes one of the other problems I've mentioned, now all of the people who created servers for the MCP need to update their servers to the new protocol, and all of the people who create clients now need to support both the legacy options for the servers and the new options. This has been seen very recently, like I think a month ago or 1.5 months ago, when MCP changed their transfer protocol to HTTP streaming instead of SSE. And everything now has this already kind of legacy problem. The problem of this is that this results in a very high cost of change. So companies are very slow to adapt this because it's going to change. So why do I adapt it now? I'm just going to wait for everyone else to do it before and for it to standardize. And once more companies adapt it, it's going to get MCP be more reluctant to actually update the protocol and improve it, because every change now breaks the entire ecosystem. Putting it all together into the core question, how should an agent actually interact with an external tool? Well, MCP comes with the first solution and says, what about a middleman? They force all traffic to go through their protocol, transfer protocol layer. Then they require writing a wrapper for your tools. And then the MCP or you have to reinvent your whole authentication, security, all of the concerns. I come with a different solution, and I say, why do a middleman when we can just do a manual where we just teach the client how to interface with the native tools of the native interface of the tools we're using, and then the protocol just gets out of the way, so that the agent can talk directly with the tools. And this also leverages existed, battle-tested security, authentication, payment, and everything else. How would something like this look? Well, I named it UTCP, which stands for Universal Tool Calling Protocol. And I kind of designed it with this philosophy. It should be a tool calling protocol which is descriptive, which is a descriptive manual, but not a prescriptive middleman. So the protocol tells you what tools are available and how to use them, and then gets out of the way to let the agent, through the client, call the tools. How does this actually solve the core problem? Well, first of all, the manual doesn't actually need to be a different server. The manual can either be part of the tool for the person who provides us the tool or the server who provides different tools, or it can even be just a file, a text file on your computer, which configures this. We've seen this already for MCP. With MCP, you also need to configure stuff with the JSON file. You can do the same here. The manual on how to use the tools basically is just it could be a JSON file. So by doing this, first of all, the first problem, the wrapper tags, we don't have any wrapper tags. We just basically read a description of how do we access the tools, and now the client knows how to interface with the tools. We leverage existing infrastructure. Authentication and everything which exists can be done as the UTCP provides different options for already existing authentication types. And finally, it's efficient and direct. We don't go around the whole MCP. We just would learn how to call the tools, and then the agent starts using the actual tools itself. The coolest part about this is actually the UTCP manual is a tool itself, if you think about it. You just get a tool with no parameters and get back how you call it. So this manual can then be provided in a bunch of different ways. As I said, it could be a JSON file on your computer. It could be a server running somewhere. It could be maybe a registry of approved tools, which are good. And this solves a bunch of other problems that the MCP is currently facing. Now that I hope I kind of sparked your interest in this, and I'm hoping for some really spicy questions, I will take some time to present myself. I'm Razvan-Ion Radulescu. I'm the CTO of Bevel. And at Bevel, we do basically legacy software modernization. So if any of you have any connections to banks, insurances, Mittelstand companies looking for modernization, I'm happy to talk. And if you have any ideas and any criticisms to add to either MCP or UTCP, either head to the GitHub or to my LinkedIn, and let's talk. Thank you.
what is your solution for the response of the tool? Do you want to have some unified format for this, or how would the agent know what it has achieved?
Yeah, exactly. So basically, what UTCP is intended to do is create two entity types. We've got providers and we've got tools. So a provider basically just tells me how do I call a tool, and this is how provider looks like. So there's a type, like say CLI, and then the command, or maybe it's a text file, so it's a path to a text file. It could be a HTTP request, and then there's a bunch more other options for how to call this a HTTP request. So instead of MCP saying we now fix and we only use stdio and HTTP with streaming, and you have to build around that, UTCP goes the other way and says we're going to implement interfaces for all sort of communication layers. You just tell me how do I communicate through that layer, and I already have the implementation done. If that makes sense. And then tools are basically structured exactly very similar to how MCP tools are structured. You've got the name, you've got description, you've got the input. You also have the output, because this is something which is missing in MCP right now. Tags to be able to search through a bunch of tools easier, and then a provider to know how you can call this tool. So this is the big difference, basically. Each tool saves a provider to let you know how can you call this tool, which a provider is basically, yeah, the transport layer. I hope that answered the question.
So does it make the tool call over the UTCP provider? Or so for example, when the UTCP provider is saying, okay, this tool call requires now CLI, for example, how can the agent then actually access the CLI?
For the agent, it looks exactly the same like MCP. The agent sends the name of the tool and the parameters. But instead of sending it to the MCP client, it sends it to the UTCP client, which has the configuration of how to call actually the other tool. So the UTCP client is still something which has to be implemented, updated, and everything else. But now we don't have a wrapper around the tool. We just have to tell it how does it call the tool.
I see. Thank you.
Any other questions? Yeah.
Still, there will be same problem like there's no support for native support for the tool, calling the tool maybe. Those kind of issues, how do we solve?
So you're saying if the tool call is so complex that the AI will not be able to get the parameters itself. Yeah, I mean that's an issue which only has the solution of wrapper. With UTCP, you can still do wrappers, right? I can just do an endpoint which is made for AIs to call it through, and I just configure that through this. But just UTCP is not as intrusive as MCP. It doesn't require you to do a wrapper which is stateful and requires stdio. It allows the flexibility to still have something which is like very lightweight if you need it, but also you can do a wrapper if you need to do that.
Okay, thank you.
Okay. If there are no further questions, then I would like to. Yeah.
Sorry, go ahead.
Okay. Then that marks the end of this Applied AI Developers Meetup. I want to thank the speakers again for presenting some very exciting projects.